Last lesson we had this start of a game where if we pressed a directional button, our speed would change, and if we were to press two directional buttons at the same time, our speed would change in that direction, and the ship is going the same speed no matter whether it's going on a 45-degree angle or straight up and down or left or right. But this is kind of clunky, to be honest with you. So instead I'm going to show you guys a different way that we can do this. So instead of setting our direction based on which key we're pressing, what I want to do is I want to combine the rotating with the speed. And so I'm going to rotate with my left and right keys, and I'm going to speed up with my forward key. And my X and Y speeds will be based on which direction my ship is pointing in. So let's get started on that. We don't need any of these anymore. We're not going to be pressing two keys at the same time. Instead, we're just going to be pressing K, and that's going to be moving the ship forward. So W is going to be moving the ship forward, and my A and my D are going to be moving the ship left or right. I'm not going to do anything with slowing the ship down at all. And I'm going to have my rotating left or right inside a separate if statement. And so A is rotate left, and my D will be rotate right, or in other words, counterclockwise and clockwise. So we already know how to rotate things, right? We would just say angle, if I'm rotating to the left, angle plus equals 1. And then if our angle is greater than 359, then angle is 0. And I forgot my colon. And over here, we are going to say angle minus equals 1. And we can say if angle is less than 0, then angle equals 359. Okay, so we should be just moving back and forth now, or rotating left and right. So we're back to rotating left and right. And if we don't like how slow our ship is rotating, we can actually change our angle by 2 instead of 1 if we want to. So I think I'm going to go ahead and do that right now, because rotating by 1 degree is not great. So there we go. Our ship, that's a lot better of a rotation speed. Our ship is rotating twice as fast as before. Now the tricky part is going to be this moving forward. Okay, so what direction are we heading in at any given moment? So we are heading in the direction that our angle is pointing. And since my ship was originally pointing straight up and down, if my angle is 0, I just want all y, and I want all of my y to be negative. If my ship is pointing at 90 degrees, so if my angle is equal to 90, I want all of my x to be negative, and I want my y to be 0. Down would be positive y with no x's, and to the right would be positive x with no y values. So how do we calculate that? Well, it's not super difficult if you know a little bit about grade 10 and grade 12 math. So my speed x is going to equal something, and my speed y is going to equal something. Now, if you've taken grade 12 math, you know that radians is another way of measuring angles. If you haven't, don't worry, you can just kind of use this code and tailor it to your purposes. But radians is a different way of measuring angles. Because we're using our angle in degrees to draw our picture, we're going to have to convert. So our angle times 3.14 divided by 180, that is going to be the angle in radians now. And we can just say sine of our angle in radians. And because sine is not a built-in Python function, it's a built into math. So we have to say math.sine is going to be angle, our angle converted into radians. And the last thing we need here is a negative sign. Now we want to be changing our x speed, right? We want to hold down that W button and be able to speed our ship up from stop. And we're going to do the same thing for the y speed, except in this case, it's going to be cosine. And so we're going to go angle times 3.14. I'm going to divide that by 180. But because down is positive in Pygame, we're going to have to put a negative right there. So now when I run it, my left and right turning is still good. And if I tap that W, you can see that ship is going, and it's off the screen already. So we've moved the ship very, very quickly. Instead, what we're going to do is we are going to divide this, let's say, by 20. So it'll speed up 20 times slower. So if we rotate it and I press W, you can see my ship is going this way now. And if I press W more, it speeds it up. I can still rotate my ship and it's gliding through space. But now if I press W, it's going in the direction that I'm pressing the W in. Now there are some things that are really cool about this, but I think we need a little bit of a speed limiter. Otherwise, you can see our ship can get going really fast. So what we want to say is, let's speed up the ship, but only if our speed is under a certain amount. So we'll say end. Now, how are we going to calculate this amount? Well, if the combination of the x and the y speed, let's say, is less than 3, a total of 3, then we can keep speeding up our ship. Now I'm going to show you a very quick way of doing that. It's just figuring out the hypotenuse. So we can say math.hypot with speed x and speed y. In other words, we're finding out the hypotenuse between our speed x and our speed y, and that would be our total speed. And if, as long as our hypotenuse, as long as our total speed, combining the x and the y, is less than, let's say, 3, then we can keep speeding up. Otherwise, we're not going to be able to speed up if we're holding down W. So if I hold down that W, I'm holding it down, but it's not speeding up anymore. Now, there is kind of a problem with this. If I reach my maximum speed, give myself some space here. If I reach my maximum speed, I'm just going to keep drifting in this direction, and even though I'm pressing W and I'm trying to get back this way, because I'm at my maximum speed, I can't slow down anymore. So it would be very, very helpful if my ship automatically slowed down, sort of like there's some drag in space. So let's make a function to do that. And let's call our function slow down, or slow ship. And the only two things we need are the speeds. Now let's say we want to slow down our object by 1%. How would we do that? Well, we can just set our rate to 0.99. And then what we can just do is we can say our dx is itself times the rate, and our dy is also times the rate. In other words, our dx, every time we call this function, our x speed will be 99% of what it just was. So it will slow down over time. You could just kind of subtract a certain amount from both, but then the ship ends up being kind of weird, right? We want to slow down the x and y by the same percentage so that our ship keeps traveling in a straight line but slows down. Then we need to return these values. Return the x speed and the y speed. So down here, we're just going to always slow the ship down. So we can say speed x and speed y are slow ship with our speed x and our speed y. So now when I run it, if I start off in this direction and I let go, you can see our ship has slowed down, but it seems kind of weird at the end. It's really kind of drifty at the end there, and it's still just ticking along 1 pixel at a time. So all we can do to get rid of that is we can say, all right, if our speed hits a certain slowness, then just set it down to 0. So we can say if dx is less than 0.02 or dx is greater than negative 0.02, actually I mean and, then what I want to do, just set it to 0. Okay, so if we get between 0.02 and negative 0.02, depending on which direction we're heading in, then just set it to 0. And we can say the same thing for the y. If dy is less than 0.02 and it's greater than negative 0.02, then set the y value to 0. So just stop it in that direction. So if we run this now, if I fly my ship along this way, and I let go, you can see my ship is stopping, and it stops a bit better, but it's still going pretty slowly, I think. We'll have to make do with the 2s for now. And the last thing that we should do is we should actually have our ship bounce around inside the screen so that we don't go flying off into space. So let's call a function walls, I guess. And what kind of things will we need? Well, we'll need the x and y location of the ship, and we'll need the x and y speeds of the ship as well. Bounces an object off of the walls. So we've done this kind of code before, right? And in fact, to make it slightly better than what we've done before, we can also send a width and a height of our object so that the object will bounce off the wall in exactly the right spot. So we can just say if our x location plus the width of our object is greater than the width of our screen, you know what, we could pass that as a variable as well. I'm not going to right now. I'm just going to say 800 for now. Or our x plus the width minus the width of our object, because remember we're drawing based on the very center, where our x is less than or equal to 0. Then what do we want to do? We want to reverse our x speed, and we want to say if y plus the height is greater than 600, or our y is less than or equal to 0, and then what do we want to do? We want to reverse the y speed, and then we'll just send back our dx and our dy, our x and y speeds. So down here in our processing, we can say our speed x and our speed y are equal to walls. Now it's our ship x, our ship y, our speed, our width, right? So we can say ship x, our ship angle dot get width. So we're going to pass it the width, and we are also going to pass it the height. Along with the 2 speeds, speed x and speed y. So when I run this, here goes my ship. I'm going to launch it at this wall, and hopefully, there you go, you see it bounce back. Now it bounced a little early, so you can see it's bouncing a little bit high there. So what's going on? Well, we're drawing our ship based on the center, this center location, right? So there is a problem with our logic right up here. Because we're drawing at the center of our object, I'm going to rearrange this a little bit. It will be 800 minus our width divided by 2, or x is less than or equal to our width divided by 2. Let's just check that out sideways now. There we go, that's a better bounce. And if we fly over to this side, you can see it bounces a bit better over on that side as well. So if our y is bigger than 600 minus the height divided by 2, or y is less than the height divided by 2, and let's just check the top and the bottom as well. See, we've got a pretty decent bounce there, and on the bottom we've got a bounce there as well. Okay, so hopefully that will be enough to get you started on moving your ship around in a new way.